determine if the following series is convergent or divergent. So we got sum of 7n plus 3 raised to n all over 2n plus 5 raised to n, where n runs from 1 through infinity. So this is our given series, and the general term, this is an. We always check whether it diverges, finding the limit of an when n goes to infinity. If this is not equal to 0, then the series diverges. But this limit equals 0 does not mean it converges. It can be anything. But we want to test this because this is short and easy. So here, if we look at closely, 7n plus 3 raised to n, the leading term is 3 raised to n. Leading term in the sense this one grows much faster than 7n. So this is 3n, and on the bottom 5n, and when n is really big, the bottom grows faster, so this goes to 0. Okay, but we cannot conclude anything. If we had something like, let's say, 5 raised to n on the top and 3 raised to n on the bottom, then we know that this is not going to go to 0 because this is going to go to infinity. In that case, we could say this series diverges by the test for divergence. Okay, now we want to take help of a much simpler series whose terms are, let's say, so just take the leading term, which is 3 raised to n as we said earlier, and 5 raised to n. Okay, this is same as 3 over 5 quantity raised to n, same thing. Now we know that this series Bn, which is 3 over 5 raised to n from, we need to mass this, which is 1 through infinity. This one, what does this do? Converges, because this is a geometric series, something raised to n, with geometric series with common ratio 3 over 5, whose absolute value is less than 1. So as long as the absolute value of common ratio is less than 1, the geometric series converges. So note that this converges. Let me fix this. Converges being a geometric series with absolute value of common ratio, which is 3 over 5, that's less than 1. If this happens to be bigger than 1 or 1, then the series diverges. Okay, now we want to look at the ratio of an and bn at infinity. That is, we are trying to use the limit comparison test. So limit at infinity of an over bn, and we can apply this because every single term here is positive. So let's do that. An is the whole chunk, 7n plus 3 raised to n over 2n plus 5 raised to n divided by bn. Bn is 3n over 5, and we can take this or this, same thing, 3n over 5 raised to n. Let's evaluate this limit. 7n plus 3 raised to n over 2n plus 5 raised to n, division into multiplication. We need to flip this fraction over 3n. Now we need to distribute on the top, distribute on the bottom. But this is limit at infinity, when n goes to infinity, and we know that limit at infinity depends on the leading terms only. So instead of multiplying both, I just want to multiply the leading terms. So 3n, so just want to multiply with this. 3 raised to n times 5 raised to n, that's 15 raised to n. On the bottom, same thing, just the leading term, 5 raised to n, 3 raised to n, 15 raised to n, cancel, just 1, which is positive infinite. That means from the limit comparison test, both series behave the same. Our new series that we constructed is a convergent series. That means the given series also converges. Then by the limit comparison test, the original series or the given series in the question, given series converges as well.